In this video, I will be demonstrating non-ferromagnetic aluminum plating on top of copper. So here's the copper bar I'm going to use as my base material. And you know when we put our probe on that, we're going to have extreme skin effect because it's highly conductive. High conductivity equals low depth of penetration. But what I'm going to do is start stacking these thin non-ferrous aluminum conductive shims on the top. But first, before I start, let me take this conductivity probe and just touch it down to the copper. And I've already rotated the angle of my impedance trajectory to vector that way. So now I'm going to put down, first I'm going to erase it, and I'm just going to get a clean signal. So one time, okay? Now I placed my first shim of aluminum. Now in the last video that I did, I had aluminum on top of carbon steel, and it rotated clockwise on the outside of the conductivity curve until I was infinitely thick with the aluminum on top of carbon steel. But let's watch what happens when I use aluminum shims on top of copper. That is the first shim. There's the second one. Third one. Now it may not look like it's going clockwise yet, but as I keep stacking the shims on, if you would trace all those points with a grease pencil, you would see them start to take a clockwise spiral shape. And I think we're just about at the point of infinite aluminum thickness on top of copper. So to prove my point, first we're going to count how many sheets we had. 1, 2, 3, 4, 5, 6, 7, 8. Now that's pretty thick. Look how thick that is. It's not quite a 1/4 inch, but it's pretty thick. Let's just look at what my frequency was that I was using. 1 kilohertz. That's why I was able to punch through that. But to show that I'm infinitely thick, I'm just going to take this copper block, which is quite a bit thicker than what I just showed you. And that impedance point is going to end up right where that infinitely thick top shim is. I stand corrected. Why is it different? Because it's a different grade of aluminum. End of video.